Have you ever wondered what dangers lurk in the vastness of space beyond the safety of our Earth's atmosphere? The grandeur and mystery of the cosmos tend to overshadow its unforgiving nature, a realm not meant for humans. Yet we, the ever-curious species, dare to venture into this unknown, exposing ourselves to the unseen perils of space. One of the most prominent dangers astronauts face in the great expanse is radiation. Unlike on Earth, where our magnetic field and atmosphere shield us from the majority of harmful rays, space offers no such protection. There, astronauts are exposed to high-energy particles from the sun and beyond our solar system. This constant bombardment of radiation can lead to serious health problems from cataracts to cancer, and even changes at the genetic level. This is not merely a hypothetical scenario. Real-life astronauts have experienced these effects firsthand. Take for instance Scott Kelly, a veteran astronaut who spent a year aboard the International Space Station. His prolonged stay in space exposed him to an environment where the radiation levels are over 100 times higher than on Earth. Upon his return, scientists found that his genes had undergone changes, a testament to the profound impact of radiation on the human body. Furthermore, radiation isn't just a danger to the body, it can also wreak havoc on the mind. Research suggests that cosmic rays could accelerate the onset of Alzheimer's disease in astronauts. This is a stark reminder that the challenges of space travel extend beyond the physical. They encompass the very essence of our being, our health, our longevity, and even our cognition. As we can see, radiation poses a significant threat to those daring enough to venture beyond our planet. It's a silent and invisible danger, one that can't be escaped once you've left the safety of Earth's magnetic field. It's a stark reminder of the risks astronauts undertake when they step into a spacecraft, leaving behind the familiarity and protection of our home planet. And yet, the allure of the unknown keeps drawing us back into the cosmos, ever willing to face the unseen perils of space. Yet radiation is not the only danger astronauts face. Have you ever considered the effects of living without gravity? Let's delve into the void of microgravity, an environment where up is down and down is up, and the rules of terrestrial life no longer apply. In this weightless world, the human body undergoes some startling changes. The most noticeable is perhaps muscle atrophy. Without the constant pull of gravity, our muscles, including the heart, begin to weaken and shrink. Astronauts have reported losing up to 20% of muscle mass on space flights lasting just 5 to 11 days. The effects are not limited to muscles alone. Bone density also takes a hit. In microgravity, the skeletal system, no longer bearing the weight of the body, starts to lose calcium and bone mass. This phenomenon is similar to osteoporosis here on Earth, but it happens at an accelerated rate in space. Astronauts can lose up to 1.5% of bone mass per month, primarily from the lower body and spine. Now let's consider the experiences of those who've spent extended periods in space, like the crew of the International Space Station. Astronauts on the ISS live in microgravity for months, sometimes even over a year. This extended exposure amplifies the effects of muscle atrophy and bone loss. To combat these effects, astronauts follow rigorous exercise routines, clocking in approximately 2 hours of high-intensity workouts each day. They use specially designed treadmills, stationary bikes, and resistance devices to provide the necessary physical stresses that our bodies need to maintain muscle and bone health. Despite these measures, returning to Earth's gravity after a long-duration spaceflight can be a challenge. Astronauts often need to undergo physical therapy to regain their muscle strength and bone density. Microgravity, while an exciting concept, presents a unique set of challenges for those living in space. Despite these hurdles, the human spirit of exploration continues to push the boundaries of our knowledge and capabilities. After all, the stars are the ultimate frontier. And what about the silence? Can the lack of sound in space affect an astronaut's mental health? In the vast expanse of space, the absence of sound is a constant, unyielding reality. Our ears, accustomed to the symphony of life on Earth, meet with an eerie silence that can seem almost deafening. This sensory deprivation can have profound psychological effects on astronauts during extended missions. Imagine, for a moment, floating in the endless void, with only the hum of your spaceship for company. Humans are social creatures, and the isolation experienced in space can be deeply unsettling. Astronauts have reported feelings of loneliness, a sense of disconnection from humanity, and even depression. The lack of familiar sounds, from the rustling of leaves to the chatter of people, can deepen these feelings of isolation. Take the experience of NASA astronaut Scott Kelly, who spent nearly a year aboard the International Space Station. He shared his feelings of profound isolation, saying that, Despite the extraordinary views and the company of his crew, he often felt alone. He described the experience as a perpetual existential crisis, a stark reminder of the psychological toll of space travel. In addition to isolation, astronauts also face a disruption of their circadian rhythms due to the absence of a natural day-night cycle. This can lead to sleep disorders and exacerbate feelings of disorientation and depression. NASA, aware of these psychological challenges, provides mental health support to astronauts during their missions. This includes regular communication with psychologists on Earth, as well as access to movies, music, and other forms of entertainment to help combat feelings of loneliness and sensory deprivation. The mental strain of space travel poses significant challenges to the future of human exploration. As we venture further into the cosmos, the psychological welfare of our astronauts must remain a priority. We must continue to research and develop strategies to mitigate the effects of isolation and sensory deprivation. Clearly, the mental toll of space travel is a serious concern that must be addressed. So, what have we learned about the dark side of space? We've delved into the unseen perils that lie beyond our Earth's comforting atmosphere, discovering that space is not just a void, but a battlefield where radiation constantly bombards anything in its path. This radiation, invisible yet insidious, poses a significant threat to astronauts, potentially causing severe health issues. Then, we ventured into the realm of microgravity. It's not just about floating fun, but a condition that can lead to muscle and bone loss, among other health concerns. Indeed, our bodies, so perfectly adapted to Earth's gravity, face a stern test in the weightlessness of space. And finally, we confronted the silent enemy, the psychological challenges of space travel. The isolation, the confinement, the alien environment, all can take a toll on an astronaut's mental health. As we continue our cosmic journey, understanding these risks becomes paramount. Space, as beautiful and mystifying as it is, holds dangers that we must prepare for. After all, knowledge is our best defense against the unknown.